Hi, my name is Vincenzo. I'm doing a thesis with Gian Antonio Roberta, that is my tutor, and a supervisor, that is Bona Basilio of the Automatic Engineering. My okay, okay. About my thesis, I'm starting with robotics swarm research, focusing on the scenarios applications algorithm and the design of a new algorithm for collective behaviors, starting from a local interaction and a specific interaction between among robots, real robots. Starting from this specific and expected behavior, I want to find out the emergency of a collective behaviors among agents through the local interaction among agents and the environment. So swarm robotics can be realized as a multi-agent systems with use of collective behaviors. We can find three kinds of behaviors in swarm robotics. Spatially organizing behaviors in a pattern and in chain formations. And this spatial organization is even helped with the navigation behavior, like flocking. That is a behavior exhibited by flocks, a group of birds which are searching for foraging or when they are in flight. And also with navigation, another important collective behavior in swarm robotics is the collective decision making with a distributed algorithm, with collective organization of the knowledge distributed in equal mode in all of the agents presenting in a specific field. The basic flocking concepts are the use of the autonomous agents capable of an own intelligence and capable of coordination among themselves. There can be virtual or physical robots. So they have to follow three important algorithmic rules. That is cohesion, that is maintain a pattern formation during their task. The alignment during their work, because they have to follow a complex and a common direction, and they have to follow a common path, and the minimum separation in order to avoid the collisions and the harms between and among the agents. Disable one of these rules will remove the cooperation among entities and make flocking impossible. It is the most important rule in flocking. For what about my thesis? The aims are the analysis of the real robots, that is the swarmbot robot that I have at this moment. Test his robustness and performance. After I'm going to realize model and simulations with NetLogo in order to create the algorithms to implement in my own environment and developing environment, and implementing flocking behaviors like leader following or an autonomous behavior in a large field. With a group movement and containment, and with the obstacle avoidance, and even with a communication using a radio module. In fact, in the hardware, I have an ATmega 16, an 8-bit ATmega 16 with 8 megahertz. We have two sensor modules, that is the obstacle avoidance present in the bottom of the robot, and the line follower. Okay. And the line follower, and the obstacle avoidance present in front of the robot. The line follower is present at the bottom. I have the actuators, ADC motors, and a communication system, a 2.3 GHz radio module present in this area of the robot. And I will use it in order to make a communication and realize a communication among the agents. The model will be done with the use of NetLogo, that is a simulated environment and modeling environment, and it is at the same time a multi-agent programming language. But our interest with NetLogo is realize algorithm and model flocking algorithm before their onboard implementation. In the next slide, I want to show, okay, one of the common behavior presented with the use of flocking algorithms and the use of 500 of population. That is starting from an autonomous behavior, an autonomous movement. All the agents collaborate among themselves in order to achieve a common behavior following deterministic direction, and using algorithms in order to maintain a cohesion and a minimum separation, in order not to collide among themselves. So, for what about my thesis? Okay. Our next task, our final goal is so to realize a common movement among an environment and even avoid obstacles through a common interaction among these robots, able of communicate among themselves. Start the demo with the use of a PC or the use of another system like the IoTS system that the other students are developing, with which I am working with. And stop. Thank you for your attention.